Lasers?
None of them are done by lasers. They were all done using surveying equipment.
What kind of surveying equipment?
I was using total stations and theodolites, but I used the total stations in theodolite mode. Jay Tolan used a surveyor's theodolite, and Bev Tried Thinking used a surveyor's auto level.
Okay, what does a theodolite do?
It measures angles relative to, well, it measures horizontal angles relative to wherever you zeroed it for the horizontal axis, and then it measures vertical angles relative to plumb or to level. You can set it to read out relative to plumb or relative to level if it's an electronic one. If it's a purely mechanical one, then it just reads relative to plumb only.
So not drop over distance, just measures angles off of itself, zeroed. That's all. So you zero the device, and then if you tilt up, it's a positive angle. Tilt down, it's a negative. Ta-da. Look at you go. You can use one now.
So he's not actually measuring drop over distance, he's calculating it.
Yeah.
So it doesn't even prove anything then.
Well, but on what basis? What's your reason that a calculation invalidates a measurement?
Because it's not a measurement.
Because a calculation assumes you're assuming the Earth is a ball when you're calculating it.
No. I assumed that Earth was flat when I calculated all of that. I just used plain trig, plain as in on a plain Earth, a plain.
Well,
So you wouldn't have to do any trig. You
There
just
you
do
go.
a direct
Welcome to
measurement.
Flat Earth. Yeah, there you go. Welcome to Flat Earth.
You've just proven it's flat Earth, Jesse. You're in our team now. That's it. It's as simple as that.
But the curved missing height line did not match flat Earth.
There's no curve missing height line. You've generated a curve of best fit using multiple individual tests, and you've cherry picked that, put it together, and gone, "Hey, look, it matches a curve that we want." That's what you've done.
Yeah. You don't get to do that. This is supposed to give you the information required to come to the conclusion of the Earth's shape and form and dimensions. Not have a preconceived idea of it already and see if it matches that.
But anyways,
It's supposed
welcome
to
to the team, Jesse.
Yeah.
Thank you.
I mean, wouldn't you expect that there's something that you could do, like having no idea of the Earth's shape and form, right? It's geometry, no idea, and you go out and you perform this thing, and you go, "Oh, discover! There it is, measurement. There it is. Like that's the discovery, right?"
And what would that thing be that I might do?
Fucked if I know.
Well, how about what would I do to measure flatness within a margin of uncertainty?
I reckon seeing across a 20-mile body of water to clear to the other side's pretty good.
Well, unfortunately, that depends on the right kind of weather for it to happen frequently. And in my area,
Prove it.
what do you want me to prove?
Prove it.
I mean,
To prove it relies on a certain type of weather.
So it has to be raining, mad sunshine, hail. What weather conditions do we require to get this to happen, Jesse? Oh, he's defaulted back into type mode. Jesse, what weather conditions do we require?
I mean, like I have a justifiable a motive, right, to see if it's that jives, because water on the small scale looks and measures flat. We use it as flat, like it's nature's reference to flat, horizontal, right? So I go, okay, wonder if it's like that across 20 miles. Oh, look at that. If it's curving, it ain't curving by much.
And now he's backing himself into a corner. Why calculations invalidate a measurement. Because that's all we're after, Jesse. It's just a measurement. Nothing more, nothing less. And when you come here with calculations after they've been twisted through some formula, which you seem to want to sidestep and not explain. Jesse, that's what we're trying to get through your thick skull. You don't need a formula. If you're doing direct measurements, that's it. They're direct measurements. You don't have to bend it or twist it through a formula. This is where you keep messing up. A measurement is a measurement. If you measure the width of your computer desk or your kitchen table, you don't then have to go and twist it through a formula to make sure that it's right. You've done your direct measurement. High fives, happy days, go and measure the next thing. How do you do a direct measurement with a margin of uncertainty? Well, guess what, mate? You're the one that's in here always preaching about how we fuck up with refraction and how you've got it sorted out. So how about you get your margin of uncertainty and work it out for yourself? Because it doesn't matter what you say now, Jesse, because you need to have a step back and have a think about all the times that you've baffled people with bullshit in here. There's your margin of uncertainty. All the crap that you've spoken of that we're going to throw back in your face. Well, if you think it bends upwards, best of luck to you. You just keep appealing to refraction, mate. And when I say appealing to refraction, I don't mean you're sitting here out in the open going, oh, but refraction. No, 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 no. When I say you're appealing to refraction, you're putting things through formulas, 7/6R, and your other one that you use quite frequently. You're either doing these measurements clean up, or you're not. Which one is it? No one really cares, but from what we've noticed, you preach one thing and practice something else. And that's how, I don't know if you're doing it deliberately, so you're just a snake, or if you just don't get it. I'm praying it's the second one.
I mean, the reciprocal zenith angles are interesting. I won't say they're not. So there's just no way that you can. There's no way that conditions could exist within the air that would produce that would result in there, not being a 2.7 mile distance horizon. Like, and you just see clear across 20 miles of water. What sort of conditions could exist in the air to produce that? What?
A vertical temperature gradient of 0.13 degrees centigrade per meter.
Really? That'll bend the light in the way that you need it to.
Yep.
Okay. Fair enough then. I guess that's the ball then.
Excellent. So have you got these air temperature measurements to validate your claim? On top of the fact that you've already measured it as curved, so you'll need these air temperature measurements to validate your refraction over the top of your curve. Best of luck.
I mean, don't you find it interesting, Jesse? Like, don't you find it interesting that you can see that far? And it doesn't look like there's any sort of miraging going on or anything, like severe distortion. Like, wouldn't that much light bending and those sort of conditions result in some really funky looking scenery?
I'll get you a picture of why I have a different view on that than you.
Okay. Don't you think it's interesting though? That it just looks like, in a span of 180 degrees, just looks like it's all just flat. And the conditions are just perfect in a large scale area like that, across all that water, left and right, forwards and back. It's just all the perfect conditions, just right to make 20 miles of water just appear flat. No sign of a geometric horizon. No sign of bottom-up obstruction. No, just straight across. You even see the reflection of a laser on the water.
Yeah, it's the whole
And the lights.
The reflection
And the lights
thing that breaks it.
Yeah. You even see reflection of lights from the streets up just up from the shoreline on the water.
I thought he was posting a picture, not a freaking essay.
How far is that?
2.6 miles.
I'm talking about 20 miles, 21 miles, bro.
But look what happens at 2.6 miles.
What happens?
And the water that's in front of your little lighthouse
What am I
there,
looking at?
how deep is it? Because as with Lake Pontchartrain, because it's exceptionally shallow, it heats up, thus giving you miraging effects which are somewhat exceptional. See, these are all things you got to look into, Jesse. You're just throwing a picture out there going, I got a gotcha moment here. No. All you're doing is throwing shit at a wall and hoping something sticks.
I must say that was a great impression.
Yay!
That was a great
Thanks, AJ.
impression. I was confused whether it was actually you or Jesse there.
Water always cold here. So that's great. How did you come to that conclusion? Or are you just throwing more random stuff out there?
So I got a question for you, Jesse. I don't know if you've ever seen it, and I don't even know what flat earthers think about it because there was something that came out a while ago. There was that convex Earth where they went out and they did laser tests, they did surveying, they did all these types of different things. Now, apparently, it wasn't a different language. I give it that, and they were translating. But apparently, they went and employed a surveying company that had nothing to do with flat Earth or any of this topic. And they went to him and said, basically, we want to measure the bases and the tops of these buildings at these locations, this distance apart, whatever it was. It was a couple of 100 miles or whatever it might be. And these guys these surveyors were apparently laughing at them and saying, there's no way that the tops are going to be the same as the bases. They have to be leaning out by this many degrees due to the distance and the curvature. And when they measured it, they found that the bases and the tops were exactly the same.
Oh, I am vaguely familiar with that. It's been a long time since I watched it, but they used GPS to measure it, and
Yes, correct.
that's all the details. They actually didn't include the raw values, and so it's like a GPS gives you a latitude and a longitude. If you go straight up above your first point, it's going to give you the same latitude and longitude. So if you then go put those two latitude longitude pairs into a haversine calculator until you're at the surface, it's going to give the same distance because you're telling it you're at the surface. So I obviously I would love to find out what they actually did, but they don't give you that in the document. They should have told you what coordinate system did they set their GPSs to, and how did they determine the distance. But they didn't give you any of those actual details, so that was disappointing to me.
Okay, fair point. I'll take that.
Yeah, well, Tibet Conspiracy's Great Salt Lake was cold conditions, and it was daytime and nighttime with no fluctuation. That well, he didn't have crosshairs to compare, but he still saw a cross. Took daytime and nighttime shots of the shoreline, the whole smokestack still in view. It's like how many freaking feet? A couple 100 feet or something high, and a laser test at night under cold conditions. None of your hot air. No, they tell us that the Chicago skyline thing was a mirage, right? And then you actually go to Joshua Newicky's page and watch some of his time lapses where he's like, it's probably late afternoon, and he time lapses it into the evening. Stays there. Horizon doesn't go up and down. The buildings don't go up and down. They shimmer and sort of wavy a little bit. There's no like this like sinking back down behind the curve, like the weatherman said. Oh, you wouldn't usually see this. All right, yeah, okay, we're seeing it because of the air inversions, the temperature inversions, blah 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 blah. Right, it's all this fucking refraction going on. Well, show me where it's like sinking back down behind the curve again, and then lifting back up. Show me it lifting up. Doesn't happen. It doesn't happen. It's just bullshit. You're seeing the city. Yeah, maybe there is a little bit of light distortion. It's not quite in its like proper place, and there's compression and all that shit going on. But it's just there. You're seeing it because it's there. And when you can't see, it's probably because it's freaking hazy. Yeah, weather conditions do prevent you from seeing further sometimes because you can't see through the freaking conditions. Because the light's bending and doing all this crazy shit. I mean, saying all this stuff about refraction is giving you the ball. It's saying, oh, okay, the Earth's a ball then. Like, basically. Like, you're trying to justify the appearance of there being no curvature by claiming now there's a curved gradient in the air.
Check out the picture or the infographic I just tagged you with. I actually compared two different of his time lapses, and the YouTube hashtags or codes are in the.
Show me it going all the way back down.
Hear me out.
Completely under the. No, Jesse, show me it completely under the curve. Show me it dropping right back down completely under the curve. Because you shouldn't see any of it. You should not see any of it over 56 miles.
As the day goes through, what T-Dub is saying, or T-Buggy today, it should start off with nothing. You can't see buildings. And as it heats up, you should see the buildings start to tower above the horizon. And they'll get to a certain point, and then when it cools down, you should see them shrink back away to nothing. That's what the time lapse should show. You've got two time lapses there. Congratulations. Both showing the buildings above the horizon. Congratulations. You should be able to see on it. Nothingness, buildings pop up, like as if they're growing, and then they should shrink back down, and we should see nothing again.
Well, their own side gives an excuse for that anyway that doesn't involve curvature. They just probably wouldn't say it'd happen over a certain distance because that's where the curve's going to be, right? But they still claim that sinking effects can be produced by the bending of light without a physical geometric obstruction. So obviously before the distance, right? Before the curvature distance. So while you still got a direct line of sight to everything, like to everything in before the curve, it can appear to go down behind the horizon and then come back up. So even if you did show me that, there's an excuse your own side has, right? Potentially for why that may appear to happen on a flat Earth. But it still would be, solid for you guys to just show that, show that, yeah, like Matrix was saying. What? Yeah, fair enough. But why does the globe? Why should the globe get any free passes, Jesse?
Oh, it shouldn't. I don't
Right.
give
So
the globe any free press.
So then you can't appeal to refraction then.
Well, why not? If I have personally measured extreme refraction conditions close to the surface, then why
You
should
haven't
I?
measured that.
Listen, when globers say refraction, they're saying, no, you must accept and account for the way we say light is going to behave when if the Earth is a ball and the air is curved this certain way, right? The gradient's curved, and if everything's exactly the way we say it is, then you've got to account for that. Well, we might as well just say you've got a globe, right? I mean, what sort of long distance observation is going to do it for you? What's a horizon distance that you would see that you would say impossible? Globe can't explain it.
Something that was self-consistent and never went outside of a very reasonable margin of uncertainty.
Just asking for a maximum. What would be a horizon distance that you would consider to be unexplainable?
Well, 1,000 miles would probably be getting pretty close.
Well, it's going to have to be right a percentage, because we got differing observer heights, right? So are you saying 1,000 miles from what, a 1 foot?
Get one observer on a mountain peak and another observer on another mountain peak 1,000 miles apart.
I'm talking about the horizon.
Exactly. If the Earth is a globe, the horizon will come up between there and block off the laser beam. If Earth is flat, it's a straight shot, right?
No, I'm talking about water. I'm talking about water in the way. Water.
Okay,
Hill of water.
Okay, two mountains that are 1,000 miles apart with water between them.
I'm just talking about a horizon distance.
Well, if the laser goes from one mountain peak to the next mountain peak 1,000 miles apart, there's obviously the horizon was farther than 1,000 miles, right?
No, I'm talking about a visible horizon.
What about a radio wave? You consider that?
Casey. How's it going? I have thought about that a lot. I am, in fact, I hold the highest possible amateur radio license class. I'm definitely into radio. But radio has much longer wavelengths and does all kinds of crazy things. Like, I have a friend, I think he's like 50 miles away, and even on a flat Earth, there's a little mountain ridge between him and I, so it's actually not line of sight. But he and I talk all the time on our ham radios, and we come in crystal clear to each other, even though there's a little mountain ridge between us. So it's like, and that's even if Earth was flat. If Earth was a globe, then it'd be even worse. But even if Earth is flat, it's still not line of sight. But we have perfect communications on 144 megahertz. So I know that
that's awesome.
Radio doesn't have that hard cutoff line like
horizon distance, T-Dub. If you're after 1,000 miles, 1,033 miles to the horizon, you would have to be 700,000 feet eye height.
Right, but Jesse's not saying that. He won't give me a maximum distance to the horizon.
Yeah,
in his eyes would falsify the globe.
He'll give you some stupid number that you can never ever back. It's like, hey, today's weather visibility is 23 miles, but Jesse wants 1,000. So, yeah.
Well, if the light is bright enough, it'll go a long ways.
Not that
okay,
bright.
so you won't. So like you haven't accepted, like beyond 10 miles at least, right? From 1 foot, nor 8 foot. Okay. Let's say 8 foot, 6 to 8 feet. All right. What if you could determine that the horizon's beyond 30 miles? Does that falsify the globe?
No, because I know for a fact
Right.
that
What about 40
light,
miles?
I know for a fact that even if Earth is flat, I still know for a fact that light can curve downward under natural conditions equal to or greater than 8 inches per mile squared. So, knowing that, I
You
know
don't
it's
know
100.
So where have you got this proven? You keep saying this is factual, like as if there's a science guy that's going to step out here and say, I've done this test and I can back what Jesse's saying. You keep decrying this as fact. Where do you get this information from? And don't fucking clam up on me now. You keep preaching this as fact. Hold up.
You guys see his 3 mile experiment video?
Hold up. He's going to answer this question. You keep saying this is fact, Jesse. Where are you getting this information from?
I'm going to put it in the side chat because obviously you're not going to let me talk. So, I'm going to put it in the side
Well,
chat.
you sat there fucking quiet. You're a coward. You get the opportunity to talk and you don't. And then when someone does overtalk you, you have a big whinge about it.
Well,
How are you claiming this information as fact? What has been done? Where have you got this information? That's your turn to talk, Jesse.
Yeah, the problem with these opportunities is that they end as soon as I try to take them.
Yeah, less meta. Where did you get this information to claim it as fact?
Well, if you're just going to yell at me and text me, I'm going to eat dinner. See y'all later.
Where did you get the information that coward? So that's I don't have the information to back it up.
Where does he live to be eating dinner at this time? Because if he's in the US, it definitely ain't dinner time.
Jesse
Might be
doesn't like
breakfast.
me much. Notice every time I spoke, it was quiet for at least 30 seconds.
Yeah.
There's got to be something else. There's got to be something else going on there with that little 3 mile, 2.6 mile observation he did.
Yeah, that's what I'm saying too. Yeah, I got him to bet me the other night that I said I'll come to where he's at and go check it out, and he's willing to bet me that whatever that test was, 3 miles.
Right.
And I'm sure that's what he's basing it off of. I don't know how.
That lighthouse and the other house seem squished and widened, like the whole building itself, the windows shortened and widened.
I haven't watched it yet, but he's willing to take me there to verify it. So I think I'm going to take him up and fly a couple people out and make a weekend of it.
Have you got a decent camera, Kingsley?
Oh yeah, you bet.
Has it been spectrum converted, or is it just like it's a DSLR? What is it?
It's just I have a P900 and a P1000.
Oh, excellent.
But I was telling him. Sorry, go ahead.
I was going to say, can you afford to grab a IR filter to screw on the front of it?
Yeah, for sure. Like if I go there, I'm for surely going to do that. I'll definitely be taking that.
If you do it, you'll need to mount it on a tripod and you'll need to set it for a long exposure. You're probably looking at about 30 seconds because you haven't had the spectrum conversion done or converted to IR. So if you're using a stock standard camera and you're trying to do IR photography, so you'll want to have a ND72 or higher. and you'll want to have it on about a 30-second timer. So do you know how you can set a 2-second delay before it starts? You need to set that and have it on a 30-second timer. So you click the button, zoom in on what you want, click the button, let it run its 30 seconds, and you'll get the photos. You might have to set your white balance because it'll come out as purple or some shit like that. But yeah, if you can, chuck an IR filter on there.
Yeah, for sure I will. Yeah, it's weird. The other night I was talking with him about it, but I was telling him I've lived on my lake for 20 years, and for the last 15 years I've never not seen my neighbor's dock, my buddy's dock, and he's about 8 kilometers away. I've never not seen his dock. There's never been a day where I went out to view it and I couldn't see it. So I don't know how at 3 miles he's not seeing laser lights. Like you're right, something's up. That's why I want to go there and confirm it and see what's up. But he's he's hell bent. He's set on it. Like he's willing to bet me. So I think I'm gonna put him to it.
So what's the actual bet?
He didn't want to bet much. I'll bet whatever he wants, but he
No,
didn't want to
not
bet
cost
much.
wise. As in, what were you betting against? You're saying X, he's saying Y.
Just he's gonna take me to the spot where he shot that video, and I don't think there's any way that he doesn't see, my laser or my mirror flash at 3 miles. I haven't watched his video yet, but there's no way, just out of common sense, at 3 miles, there's no way he's not going to see my laser or my mirror flash.
There's reasons why he picks these very specific locations. Keep that in mind because he's a dodgy bastard.
Yeah, for sure. I if I was betting big or something, I would definitely. But he just wants to do it for $100 or whatever, right? So I'm down to I'm down to take the gamble. But he was even telling me I'm I'll fly you out wherever you want to go. I'll fly you here or I'll come there, whatever. He's like, as long as I can pick the atmospheric conditions at 3
As
miles.
long as he can.
Yeah.
Enough said. Yeah. So what he's doing is cherry picking very specific days so he can get the conditions he's after. That's what he's doing. That says enough. Because if anyone was honest, they'd just go, mate, whatever day you rock up, we'll go and check it out.
Yeah, for sure. I just don't think at 3 miles there's anything that he could pick or do to make him not see my light at 5 feet observer heights. It's impossible. I've been doing long distance observations for the last 10 years, and I've never not, like I said, I've never not seen something at that distance. It's never happened to me. And I I haven't watched his video yet. Funny enough, I saved it, but and if it is, then well, cool. I'm wrong, but I want to see it.
When you do go to your place, not that you probably won't have enough shit to carry as it is, if you can take a thermometer with you, get water temperatures.
Yeah, for sure. I'm gonna bring everything I possibly can and do a whole lot of homework before I leave. And
he gets his notepad out, adds to the list. Thermometer, matrix pain in the ass. Says take this. No, but I'm just so you cover your ass, mate. Because fair income, he's picking these very specific conditions for a reason. So if you go there and you find that the water temperature is 20 degrees hotter than the air temperature, it's like, hang on a minute. Of course you're going to get some kind of effects if you're shooting low across the water.
Yeah, for sure. And he was actually telling me about that spot. He's like, it's one of the only spots where the trees it holds the heat, and then once the sun goes down, it comes out over the lake and it does some really weird stuff. So he knows what he's maybe talking about, but I just, even then, I've sat on my lake for, like I said, 15 years at minus 40, minus 30, minus 20, minus 10. It doesn't matter. I've done it every single day at every single temperature, at every single, condition that I could. I've never not seen that dock ever.
Yep.
So for me, that, like, maybe it's possible, and if so, I'm willing to buy a steak dinner and lose my $100 and howdy ho.
No, there'd be something dodgy going on.
Yeah,
I'd be willing to throw a lazy 100 on that.
Yeah, that's exactly why I want to go.
Well, at least you can go and suss it out. So if you go there with some measuring equipment, like if he turns around and claims refraction, I thought, how are you going to give us refraction? He started to tell us about it had to be a per meter. It has to be 0.13 of a degree or greater per meter. And what has he got to back that up? What measurements has he done that backs that call up in any of his tests? And then you question his tests and have a look through them. 7/6R. Oh, this one's heavily refracted. That's why we had to go up in the mountains. Like every single test, he's adding refraction, but yet he's going to places to mitigate refraction. So which one is it? Are you deliberately trying to get around it and avoid it? If so, why are you adding it back in? Like,
yeah, exactly. Yeah, totally. Something stinks.
Yeah. Well, at least you're going to be able to go there and see it firsthand. So that'll be good.
Yeah, you bet.
I don't know how you're going to mount a selfie stick on him so he can't undo it. Actually, what you do need is you need another volunteer to be on the other side. Someone that you can trust to do the laser work so you can stand beside him. And when he turns there and goes, I can't see the laser, you can just go, what is that green thing? No, not the tree. The flashy thing, you clown shoes. That thing. What is it? Bowl of goldfish? I think not. And you can film it and bust him. That'd be good.
Yeah, for sure. No, I'm totally doing that.
Because, yeah, that's what you need. If you go to the opposite side, how do you know he's telling the truth? He just sit back. Yeah, I can't see anything. I got my theodolite running.
The angle of light.
Needs to change his name to Jesse Refracted Path of Light.
Well, with that lighthouse one he's got there, what? How do you know that? Like, how do you know that as it's coming across, it's like not changing. Like there's a different temperature closer to you, the observer, than there is over there, and like it's come down a bit and then like curved back up. Like, you know what I mean? Not curved, but like change direction, like almost like concave. I mean, it's moved towards the denser air where it is. Then the temperature's changed along its way. It started coming level, and then hit some denser air above it, and then started curving back up. You know what I mean? Like, yeah, that's like, is that outside the realm of possibility to make that water appear higher than his crosshairs and his theodolite? I don't know.
Yeah, it's weird for sure, and he's so heavily invested in like these weird ones, like, and totally dismisses like longer ones. Like,
yeah,
magnitude's longer, and he's dismissing that or has no interest in it. But these ones, oh yeah, fucking here's all the shit, right? Like
that's what I said. I said 2.7 miles. What? I'm talking 21 miles. That's why I was asking him, like, what sort of horizon distance, Because, I said, what about 30? No. Okay. I was going to push him to 40 and go up by increments of 10, see where he'd, draw the line.
Yeah, that's what I was doing the other night with him too. And same thing, he wouldn't answer, dodged around and back to his little 3-mile experiment.
But seriously, when they say refraction, they basically, like, they might as well be saying, listen, Earth's a ball and there's a curved gradient and this is the way light behaves in it. You didn't account for that. Oh, I didn't account for the Earth being a ball, did I? I'm sorry.
Yeah.
Because what sort of refraction am I supposed to be accounting for? Flat Earth refraction? Globe Earth refraction? Just refraction? Like, what type? How are we determining what the light did? Come on, let me know how I account for it. You mean, like measure the air temperature and the water temperature, every 100 feet or something? Like you guys do, obviously did when you try and present imagery of bottom-up obstruction, right? You definitely took all that into account, right? No.
Exactly.
So wait a second. Wait a second here. Whoa. What? One sec. They're saying that the optical gradient, the optical density gradient, is primarily the result of temperature gradient, right? Temperature changes. Is that right?
Mm-hmm. Yep.
Okay. That generally results in a very gradual pressure gradient, right? What happened to gravity?
Well, it's different on a the air the pressure gradient, the psi goes down as you go up in altitude, and over on a broad spectrum, the refractive index gets lower as you go up, right? So if you're looking through a vast, huge distance of air, then the change in the natural pressure, how it decreases as you go up in height, would make the light bend slightly downward. But that's not what we're looking through when we're doing these observations. We're looking through a small vertical area, and temperature would be the primary controller of the optical density. It's the difference between air pressure and optical density.
Right, but what are they saying is the result? Which one's the result of which?
Well, I think it depends on the specific situation.
I mean, like, is the pressure gradient the result of the temperature gradient? Or is the temperature gradient the result of the pressure gradient?
Well, this is the thing, right? So the amount of air that we have lower, like 14.7 psi, and then it just basically you get less and less amount of the air as you go up higher. So on a broad scale, the amount of air pressure is the primarily controller of the refractive index, only on that broad scale, on that big scale. We're not taking any observations on that big scale at all.
And temperature seems to be the biggest contributing factor to reduction in PSI with altitude, correct?
There's a correlation there.
Yeah, it's definitely something that needs to be taken into account. I mean, it gets super cold as you go up. I mean, it depends if, like, there's so many contradictions in the globe model when it comes to how that works. But yeah, it gets super cold as you go up.
Yeah, I mean, I definitely would think that temperature would be a big contributing factor. Is there anything else that exponentially changes as we
I think they'd
climb an
say
elevation?
well, I think they'd say that gravity gives us the pressure gradient, right? And the pressure gradient allows for the temperature gradient.
Oh yeah, I know they say that gravity gives us the pressure gradient, but they say a lot of things. I don't pay much to that. Pay much attention to that.
Yeah, I'd say that, because of the complex dynamic system that we live in, and the gas is constantly being produced at ground level, and the gas particles moving at random in all directions, right? They're trying to fill the available space, which goes up, right? All of the space is up, it's not down. The ground's down. And then the gas particles are going to bounce off each other, bounce off the ground, and they're going to go off in all different directions. Now, as we go up higher, we have less temperature because the sun heats up the ground. And then that temperature from the ground is what gives us our warmer temperatures down low to the surface. Now, as you go up higher, then you have that temperature decrease and the gas particles are going to slow down, right? But the cold, right? It gets kind of confusing because cold air is more dense, more optically dense than warm air.
Okay. I'm
But it
I'm
starts
with you.
spacing out.
I'm with you on all this. I'm following, but I just had a thought about the difference, in this containment, in this container, the difference between, the highest pressure, the 4.7, and the lowest pressure at, I'm not even sure what the lowest claimed pressure recorded in elevation is. Or do you know off the top of your head?
No,
It's
but I
actually
think it's
like,
around 40 kilometers up. That's as high as we can.
I thought you were
climb.
talking about the 10 to the negative 17.
And
But it's actually more than that.
Do they claim a PSI up there? A certain PSI?
Actually, our friend here's onto something
Yeah.
good. If we could work out what the actual difference would be between the upper and lower limits, and then when Ice JJ Clown Show comes back again, we could go, look, this is from the top of whatever our maximum height is. This is the pressure difference top to bottom. You're only going to get 0.1 of a degree difference, and here you are claiming extra because of air pressure. Fail.
Yeah. And I also had a bigger question I was pondering amongst listening to all this is this difference between the PSI surface and the upper echelon of the containment. That would just be a result of the amount of particles available, right? with
Yeah.
they're at the surface, everything's active at the surface, produced at the surface, and it does all it can to fill that upper volume. Like you said, there's the only way to go is up. There's a ground underneath. So the difference between the highest psi at surface and the lowest psi up in elevation would just be the total particles available in the container, correct?
Mm-hmm. Yep. Yeah, so it's just a less amount of the gas particles, and then also they're going much slower because the temperature's way colder.
Yeah,
So
so
they
we could,
become
sorry.
less they become less excited and they slow down due to temperature.
Well, how come when they're what if they're in direct sunlight? Like that's not affecting them?
Yeah, there's not enough of them, It's not the sunlight hitting the
But
gas molecules that's causing the kinetic energy. It's the sunlight that heats up the ground, and then that warm air that the ground generates from the sunlight rises upward.
there's an energy transfer. I mean, but like, wouldn't direct sunlight, if a gas molecule is a particle and the ground is made of particles, right? They're different states of matter, but there's energy being absorbed and then released. Why wouldn't the gas molecule heat up from direct sunlight?
Yeah, I don't know, man. It's an interesting question.
Because they're not a piece of plastic or anything you can hold in your hand. Can't absorb.
Yeah, I would assume it would disperse the heat amongst its all the adjacent particles pretty efficiently, pretty quickly. But I'm still thinking about this big container here and the difference in pressure between the high pressure at the surface and the lower pressure at elevation. And if we took a container and based on the amount of particles we put in this container, if we let it settle, there would be a gradient in this container. And if we had a similar mixture to what we find, because that is interesting, right? Because like it's the same mixture, even though it's less pressure, right? So if we put a similar mixture in a smaller container and we could replicate the amount of pressure drop off with elevation, could we get some kind of potential information about the size and volume of the container?
Yeah, just go buy a propane tank. There you go. You got liquid on the bottom and gas on top. There's all your states of change for it. Almost. Well, almost all of it.
I got you, but you get the question I'm asking? If
Yeah,
we
Yeah,
could,
like
pressure gradients can only happen in a container. That's all I know about pressure gradients. They can only happen in a sealed container.
oh, buddy, I got you on that, man. I've been a quote unquote flat earther for a decade. I'm just been listening to y'all's interesting conversation and just had a thought about the overall size of the container and the difference between the pressure at the surface level and the pressure at upper elevation. And I was curious to what the claimed pressure is at what they claim the pressure is at real high elevation. And then I was considering if we make a similar mixture and put it in an actual container for experiment and get a similar rate of drop off to low pressure, we could get some kind of general information about total volume. I was just wondering. I was just thinking.
I think I don't know, if you have a static system, right? Like you have a certain amount of air, like in a balloon or something like that, and the temperature's uniform throughout the entire balloon. I don't think that there's any gradient There's no change. It's equal everywhere in the balloon. And
Oh,
the
I
only
got
thing
you. I got you.
I think the only thing that can change it is the temperature, certain outside effects, right? Inside, I guess, but yeah, temperature, because the temperature naturally gets a little bit cooler as you go up.
I got you. It would be hard to to even come close to replicating such a dynamic system. But I was just it would be fun to get a bigger container and put a similar mixture as our atmosphere, and add something that changes, to play with the temperatures inside and to play with things to see how you could change the gradient. That would be pretty interesting.
Yeah, yeah. Well, Sky Free kind of does that. Do you know Sky Free's channel? They do like at-home refraction tests.
I'll have to check it out.
Yeah, it's awesome. Like, so basically, they'll set up things on their flat floor at their house, and then they'll manipulate the temperatures in the room, and they'll be able to make it look like things disappear behind the horizon, and the horizon being on the flat floor, all of a sudden appearing a horizon, and things that you could perfectly see all of a sudden dip behind the horizon. And the only thing that they manipulated is the temperature in the room, which manipulated the density of the air.
Yeah, I might have seen you share one of the demonstrations before. Then I might have seen
Yeah.
it. Yeah.
Yeah, I'll show it again in the side chat. I think the best way to demonstrate an analogous density gradient like we have on the Earth is if you have like a really big terrarium or a vivarium, and you've got a similar process that's taking place like we have here on the Earth, where the gases are constantly being produced at ground level, and
Yeah,
you have that dynamic
makes, yeah.
system where it's going to be higher pressure down lower because it's constantly being produced, and then you've got all the cycles taking place in the little self-contained ecosystem. From the research I did, the larger you make these terrariums, the more of a density gradient that we have. The Globers will still say that that's just because of gravity.
Interesting.
Yeah, I mean, I don't know. Like when people say that gas particles aren't affected by, like gas particles are definitely affected by relative density in a sense. Even though on a small scale, like on a small level, the gas particles are actually moving at random in all directions. They don't have a directional bias. But I mean, if you pour out some heavier gas like SF6, it's going to go down. Right? It's going to go down. It's going to form a pool.
Just because the pressure on top of it, though.
Well, yeah, I mean, because of relative density. And then, once it settles in, let's say you just pour a bucket of SF6, you pour it into a fish tank. Right? Those gas particles, just because they're moving in all directions, doesn't mean they're just going to float off into the air, right? They're going to sink, they're going to pool in the fish tank. And then over time, the kinetic energy, the gas particles diffusion will take place, and they'll just blend in with the gas, and then the next day there'll be none of that SF6 left in the fish tank. But initially, relative density definitely comes into account.
Oh, of course. And
Yeah.
if you create a vacuum in this tank and remove the pressure pushing down on the the gas, it would disperse more quickly. I
Well, that's when
assume.
shit gets crazy. Then I mean, I guess it just it just expands in all directions if you put it in a vacuum, doesn't it? I don't know. I've not seen anyone do it with like SF6.
But gravity should hold it down, though.
Should. Yeah.
I have a
Well, I
simple
guess
experiment you can try to see if gravity holds things down, but we won't get into that now. But anyway,
what's it to do with? Give us more of a hint or a clue or something.
oh shit, I can put a cup of water. I can put a cup of water that's sitting on my table, and gravity's holding the water in the cup. and put that in my vacuum chamber and suck all the air out, and the water will turn to gas, meaning the gravity didn't hold the water down. It was just air pressure.
Yeah.
And water is some crazy stuff, man. It it behaves quite uniquely compared to many substances. I think I forget exactly, but the temperature at which it boils doesn't make any sense compared to a lot of the other elements. And
Yeah,
that's
here's the Sky Free test in the side chat.
super interesting how, basically the PSI or the pressure has to do with what temperature water boils to, right?
Yeah, man, it's interesting for sure.
That's why you go on top of a mountain that can boil water a lot lower than 212 degrees. And as Professor Triangle said there, if you have no pressure at all, you can boil it at room temperature.
Yeah, that's amazing, actually. Great point. What's up, Jedi?
Morning, brother. Hope you're well. What's going down?
Yeah. No, not much, man. We've just been talking refraction and stuff for a few hours.
For a fraction. Wow. That must
Yeah.
have been amazing.
We had Ice JJ Fish in here spazzing out with some cheerleader.
Oh, has he brought his cheerleaders now? Oh, my God.
Yeah, you had some cheerleader called Cap who was too scared to open the microphone. But it was just chat skanking. Yeah.
Oh, well.
So we were
Too many
just trying to
sharks in the
explain
water.
that.
He wouldn't have unlocked his mic.
You were just trying to explain what? What?
Oh, that temperature is the main controller of the refractive index, basically. And he was trying to deny it, I guess, because flat earthers were saying it. And then we
Yeah.
gave him a shit ton of citations that all said it. And he was still denying it. And then he shared a citation of atmospheric refraction from Wikipedia. And he cut out what it kept saying a little bit lower. And then when I went and checked, it said exactly what was backing our claim up a little bit lower. And he cropped that out.
Wow.
Yeah.
Wow. What a dishonest little boy.
Yeah, man, these people are crazy. I think I'll start an event.
Do we have a title in mind?
I don't know. I don't have one.
Time to piss Matrix off with Earth curve measurements. That sounds like a good title.
She's something horrible. How many clowns does it take to prove curvature? Let's just see how many people come in.
Did anybody watch that video last night that our friend posted? I can't remember what it bloody was called. Let me
Nope.
see if I can find it.
No, but I do plan on watching it.
Yeah, I recommend everybody does. If I can remember the bloody name of it, hold on.
So the reason that a gas molecule is not significantly heated or affected by direct sunlight is apparently due to its wavelength.
The wavelength of the light that's hitting the particle, you mean?
Right, because I pulled it up, because I'm asking it like, okay, why isn't it affected, right? And it's like, well, it's transparent; it just passes straight through it, right? um, and then it said the air at the ground so is heated up by, like, because the ground's heated and it releases heat and heats the air, and I'm like, and that's radiant energy. I'm like, hang on a second, isn't sunlight radiant energy? It's like, oh yeah. I'm like, I smell a contradiction here. What's going on, right? It's the type of energy it is. It's the length of the wave. So the shorter, the less impactful it is. Like, so, yeah. So that the longer the wavelength, it's larger. It's talking. It's basically saying that the energy has shape. Right?
Sounds confusing.
Yeah.
It does have shape.
And
Haven't you ever seen a symbol for electricity? Looks like a lightning bolt.
it comes down to resonance. It says every molecule has a specific frequency it likes to vibrate with or vibrate at. Yeah, so it doesn't vibe with sunlight, but the ground energy, yeah, it vibes with that. Sunlight doesn't vibrate at a frequency they can grab, so it passes through. Okay, fair enough.
What did you watch the whole thing, Jedi, or?
No, I fell asleep watching it last night, and I just remembered that that's what I was doing when I was falling asleep, was listening to this video, and I was just intrigued with it. Absolutely intrigued with it. Most of the stuff and I think we already know goes into an awful lot of different subjects: flat Earth, Tartaria, blah blah blah. I've got to finish the video. I'll probably finish it like during lunchtime today. But yes, it's really, really good. I was just wondered if anybody else had seen it, because it's just interested in a conversation about it, that's all. But if you haven't, we'll catch up at some point in the future.
Yeah, I'll watch it today.
Good stuff. Our friend, I can't remember his name, gave us 2 videos. This video that I dropped to the breakdown video, or somebody doing a commentary on the video or something. I haven't watched that one yet. I've just watched this one, or half of it.
Mind Shock.
Yeah, yeah.
Bruce McGuire. Yeah.
But yeah, definitely worth review.
What do you think about what they tell us about the shape of our Earth, Shino?
Um, can you say that question again?
Oh, what thoughts do you have? What do you think about what we are told the Earth is? We're told it's a planet and a globe, a flying through space. Any thoughts on that?
Yeah, I think the Earth is round, and there are like I just believe that there are uh species, not only human. I sorry, I just try to explain it, but I'm not good in English. But let me try to explain. Let me just share my thought. I
Mhm.
think there are we don't live alone. Like there are alien, let's say alien, also
Uh-huh.
there. I just believe that.
Okay. Okay. Would you be surprised if you heard about experiments to test for curvature of the globe, and the results of those tests didn't demonstrate any curvature whatsoever? It's a tough crowd this morning. Be like hitting 30, 40 G's.
I think Artemis took a sweet picture proving flat Earth.
They what?
It took a sweet picture that proves flat Earth, or at least it doesn't curve.
Oh, that
The,
one.
the one, the one with Lake Tahoe curving.
Oh, did Artemis take a picture like that? I didn't see it.
Oh yeah, they were going on there. They took a big picture of this big ball Earth that they're flying over, and they've got Lake Tahoe sitting there curving hugely from southwest to northeast. It's so huge. And per the Earth's curvature, but per your fucking eyes, per the picture, the picture, quote unquote, they fucking took, per your eyes, bro. If you're sitting on the North Shore, you would not be able to see the South Shore. It's curving too much. And guess what? You can see that. In the picture, it's flat. There's no curve at all because it doesn't. But it's like we know that doesn't curve. We have pictures you can look from the North Shore to the South Shore, clear as day without any hump. And you motherfuckers are saying there's a giant fucking hump on it. It's huge in that picture. It's just silly,
Oh,
bro. Like, tell me more lies.
that's hilarious. How far is it North Shore to South Shore at Tahoe?
That's a good question. I don't remember. It's a good hump though,
Is it?
or say it's a good no hump. I should say.
Right. I've never been to Tahoe.
Yo. Oh.
Howdy, pard.
Yo, Wild Bill.
What's going on today?
Exams coming up. Gotta study. Where are you from?
I'm from the USA.
Wow.
What about you?
I'm from Nepal.
Nepal. Oh, wow.
Yep.
Interesting.
Have you been?
Very
Have you been
interesting.
to any Asian countries?
I've never, no. The only country I've been outside the US is Canada.
Ah, okay. That's great. How old are you?
I'm 52.
Oh, wow. So, what are your thoughts on if the Earth is flat or round? I think the channel is related to that. So,
Your exam is related to that?
not really. It's
Oh,
related to IT technology, but
oh,
I would
okay.
ask a question. Yeah.
Yeah, no, that's a great question. And what I've come to learn over the past 5, 6 years of study and understanding is that all of our observations of the Earth, when we try and test for curvature, because we're told that the Earth is a globe, but when we try and test for that required curve rate, it doesn't exist. So if there's no curve, what does that tell you? To me, it says it's flat, which is a
Um,
which is a,
mhm.
a description, not a shape, but a description of the surface that we live on, and it's a horizontal plane, man.
Okay. Then, what it is like from like higher view?
Yeah, well, it's the same thing, you know, the higher you go, the more distant you can make observations, right? And
Yeah.
we see well beyond the limitations required by a geometric horizon that really don't exist. The horizon, as we observe it, is more of an optical phenomenon. It's the limitation of our eyesight more than anything, and uh, we see way too far. That there is no globe.
So it's all flat surface.
Well, it's a horizontal plane for sure. Yeah, it's planar in nature.
And then I saw one post or something on social media that if you see on flat map of the earth, then you're going from one place to another with on a flight, right?
Uh-huh.
Then the in that scenario, the flight path seemed to be a bit curved to make the distance shorter, I think. So why can't we go just straight then? That would be shorter, I think, if it's all really flat.
Well, so you're talking about flight paths as they're depicted on the AE map, the azimuth equidistant, or some people call the flat Earth map. Are you talking about flight patterns on that, or the curved great circle routes on a globe?
I don't know, the map that looks kind of flat, not the globe one.
Oh, okay. And you're saying that the routes look curved?
Yes.
Because that's peculiar. The only flight paths I've seen on that map are fairly straight. I'm not
Really,
sure
I
if
don't think so.
I'm not sure if I'm
I think
thinking
he's
of.
talking. I think he's talking about the like the Mercator projection of the globe, like the flat map of the globe Earth.
Oh, the Mercator. Okay, I follow you now. I misunderstood. Yeah, so those are flight corridors that really have nothing to do with a globe, but more so distance from um, oh, emergency services and other airports and air traffic. control, other aspects that I can't think of right now. But yeah, why they're not straight on that map. I don't believe that map's accurate, for one, and then they very well could be straight in reality, but they don't necessarily have to be, because there's other things that they're taking into account.
Okay, thank you so much for your opinion. And do you believe, do you trust the Google Earth and that kind of stuff?
No, that's a projection of a coordinate system that is an imposed imagery. It's not photography. If
Mhm.
that's what if that's the assumption, it's not a photograph of a ball Earth. It's imposed.
Okay, that's wonderful. Can I ask one question? What did you study? Because you sound very expert in what you are saying and what you are talking about this field.
Well, I don't know about that, but I'll answer the best of my ability.
Okay. The only thing that I'm doing here is practicing my English because it's so bad, and I want to be as fluent as you guys.
Oh,
Not as fluent as you guys, but I want to be more fluent, and I want to articulate what I want to say and things like that.
Oh, your English is very good. Oh, and
Mm.
you've got some good questions. Please,
Yep.
go for it. Go
Now
for
that
it.
we have talked for this so far, what feedback and improvements do you give me? What could be better? What could be
Oh,
improved? Yeah.
yeah, I'm the wrong person to ask. I don't know. Yeah, just practice is, all I really don't know what to tell you, but I think your English is very good, and yeah, just vocabulary and practice, and I really don't know what to tell you. I'm not
No,
an English
nice.
Yeah,
Yeah.
English.
the other voice channels where they actually like practice and learn English and stuff. They know more about the actual language and you say it and stuff than we do, man. This is definitely like the flat Earth stuff. So if you want to learn more from somebody who knows what they're talking about, head to those other
Yeah.
the voice channels in the Discord. They can definitely help you practice. There's other people doing it, and there's people that help teach you. That's not something we can do well for you.
Okay, okay, amazing. Thank you so much. And could you please tell me in very brief that what is this channel about? Is it just flat Earth? What do you guys discuss the most here?
Yeah, mainly the title of the channel, Flat Earth. That's primarily what we're here to discuss. Hmm.
Okay, thank you so much. You guys
Uh,
have a good one.
yeah, stop by anytime.
And yeah, to answer your question, it's 22 miles, so it'd be 240 feet of curvature.
Really? Dang, 22 miles. That's a big lake. So, 240 feet of curvature, and you can clearly see North Shore from the South Shore, you were saying.
Oh, dude, it's funny. Like, it's so easy. Like, it's so nice and clear out there because of the low humidity and shit. And it's just, it's easy. It's so clear. It's crazy.
Isn't that?
Yeah, you can look at any picture of it. There's one guy that took of like boats all across it. He could easily see across it. It's a really good one actually for seeing that far with the naked eye because it's so dry.
That's amazing. That's wild. I wonder what the globe would say. Refraction.
Gravity, bro. Gravity is holding all of that water against the earth in a curve somehow against all laws that we know. It's so funny because they act like we're in fantasy land. That's the funny part.
Yeah, they're kind of running into a dead end on gravity and refraction, so they're going to have to mix them into a mystery soup of grafraction.
Yeah, like that's good. Also had a really interesting discussion with the guys yesterday. I don't remember who it was, but we were talking about it. And this guy was claiming that we were this was a cult. He was mostly trolling, but he was like, "You're a cult, and you're just trying to get people to come here." We were all like, all of us were kind of like, for what benefit for us? By the way, like the people have been lying to us have power and money to gain. We have nothing really. I mean, maybe some power and solidarity to stand up against it, but I mean, like, we don't actually have any like personal gain from this. And he was acting like we're trying to do something like dirty and evil or something to benefit ourselves. We're like, no, bro, we don't get shit from this.
Sounds like he's projecting a little bit, huh?
Maybe, like I said, we're just trying to tell people the truth and show people how bad they've been getting screwed so they can come over here and fight when need be. But I mean, like, there's no personal gain here. I'm not getting paid for this.
Oh man. Well, I'm sure everybody here has a similar story, but the social hardships and relationship hardships, I mean, just interpersonal dealing with people and community and whatever, being a flat earther is so challenging. I mean, it's just everything's against you when you're a known flat earther. Like, what's the advantage is what I'm saying.
Yeah, yeah. It's almost like we're kind of in the negative net advantage. We're
Yeah.
taking this position. We gain nothing. In fact, we lose some, and yet we're still standing here. So, I don't know. That should lend some credence to something to some people, but nobody sees that. In fact, the guy yesterday was throwing rocks at us for it for some reason.
Yeah, it's so wild. But I got a funny story. So I was sitting at a resort bar here a few days ago, and these two gals walk up to me and they say, "Hey, are you Cowboy Bill?" And I said, "Yeah." And they said, "Our Uber driver said that if you see a guy in a big cowboy hat there at the bar, go up and ask him about flat Earth." And I have no idea who the Uber driver is. I don't know him, but it's pretty funny. You get known for it, right?
Yeah, that's what they call infamy, and it's awesome.
Infamy, exactly. Yeah. But yeah, I'm not sure it's a big advantage being known as a flat earther. There's a lot of uh, I don't know. You run up against a lot of walls with it with people, but I don't depend on it for work or anything, so I don't care. But yeah, I do get some judgment. Judgment. That's what I was trying to think of. I do get some judgment from it.
Yeah, I've only talked to people I like know from like personal life slash work slash like my customers at work slash my friends online type shit. And I've kind of run into
Mhm.
everything. So some people, like some of my buddies, my 12 old buddy from a really old long time ago, like 20 some years ago. And I showed him, he's like, yeah, of course. Yeah, we know. So he was like, yeah. And then I had like one online friend was like, it's the moment he's like, oh my God, you're a flat earth, you're a fucking idiot. And just like, oh my God, I can't listen to anything you say, it's not true. And all this kind of, I was like, all right, that's fine, dude. And then like now every time we get on, he gets on, like he's immediately like anytime I say something, he's like, yeah, coming from a flat earther and stuff. So there's that attitude. And then I had another friend of mine who's just like really receptive and like not taking everything I say again, but like just listening to me, you know. And then you have next to nobody who wants to actually learn. So, but there are a lot of like just cool friends and stuff who are just like, "Well, that's crazy," not like judgmental. It was still kind of like, "Wow, like that's out there." But I mean,
Yeah.
this world is getting weirder by the day, so
Yeah. I would say most of my interactions are positive. Uh,
it's like really receptive and like not taking everything I say again, but like just listening to me, you know. And and you have next to nobody who wants to actually learn. So, but there are a lot of my just cool friends and stuff who are just like, "What? That's crazy." Not like judgmental. It was still kind of like, "Wow, like that's out there." But I mean,
Yeah.
this world is getting weirder by the day. So
Yeah. I would say most of my interactions are positive. Um, uh, Maybe a small percentage are actually interested, but most interactions are positive. Some are not positive, but they're not terrible.